Today we're showing several microcontroller demos using Zephyr. NXP is fully vested in Zephyr, and we enable a lot of our microcontrollers today out of box to run Zephyr. And we have a few demos here that we've brought to showcase some of the advantages that Zephyr offers on our microcontrollers. This first demo is using our i.MX RT family of microcontrollers, and it's showcasing the hardware abstraction layer that Zephyr offers. So this is a close-up here of the RT1170 display. This is a MIPI display, MIPI DSi, with a touchscreen interface on here. And so we have these little VGL animations where we can change our oven temperature and the time that we're going to bake something and turn the oven off and on. It's really just showcasing little VGL running in Zephyr with a nice UI that we generated. From an application perspective, this is the same application, same source code, running on two different hardware platforms. So down at a low level, under the hood, they're using different drivers and different peripherals, but the application is the same code. We're also leveraging a tool that NXP offers called GUI Guider that's able to generate code for little VGL. So the GUI Guider UI was written in a host computer and generated the code, and then we were able to resize it to the smaller display, which uses a different interface, and we shrink the images and the fonts, and it regenerates the application for this display. So running the same application code, we're able to run on these two different hardware platforms thanks to Zephyr. Another demo that we're offering here is a smartwatch demo. This one's based on an i.MX RT500 device, which is highly optimized for wearable applications. And we were able to optimize a Zephyr application running on here. This is again using little VGL, but it's using Zephyr's power management subsystem. So when there's nothing going on in the application, like you just got your watch screen on and it only needs to update once a second, it goes into a very deep sleep mode and saves a lot of power for you. We're also leveraging a GPU on this design as well. So it's accelerating the watch interfaces and the rendering of the graphics. And that also benefits power consumption because we're able to render the screen faster and get back into a low power mode quicker. We have multiple screens that you would find on a smartwatch you would go buy. And these also help us demonstrate different power optimization techniques. The watch screens here, we have both digital and an analog screen. And these show ultra low power mode going into deep sleep mode. So they just wake up once a second, render the new screen, and go back to sleep. This is leveraging our GPU here. So the watch hands, as they change angles, that's all being calculated by the GPU to get back to sleep faster. So some of the techniques that we've used to optimize power is showcasing how to get back into that deep sleep mode as fast as possible and reduce the voltage and the current consumption when you're in that mode. We have some other advanced power features that this chip supports, including what we call a process voltage temp sensor. So it's able to, at real time, while you're using it, monitor the timing margin that's required for the device, and you can scale down the voltage and reduce your power consumption. But like if the temperature changes and it needs a higher voltage to achieve that same frequency, the hardware will wake up your device and immediately request a higher voltage. And we're able to save like 10 to 20% of the power consumption leveraging that PVT sensor. So we have all of this integrated in the Zephyr application.